Hey everyone, welcome back. In this lesson we're going to continue where we left off last time. Just to recap, last time we talked about adding and subtracting fractions. We talked about addition of proper fractions. So like that would be something like 2/3 plus 4/7, let's say. And we also talked about subtracting fractions, subtracting proper fractions. So where perhaps you could, instead of having a plus sign there, you could have a minus sign instead. So addition and subtraction of proper fractions isn't a particularly complicated topic. At least when you compare it to mixed numbers, dealing with proper fractions is much more straightforward. And so we talked about adding proper fractions, we talked about adding mixed fractions, or mixed numbers, and we talked about subtracting proper fractions. But when it comes to subtracting mixed numbers, things get a little bit more complicated. So far we've only dealt with subtracting proper fractions. Now we're going to deal with subtracting mixed numbers instead. Now, if you remember, when we were working with adding mixed numbers, there are two ways to do it, right? The first way is that you convert everything to an improper fraction, or to groups of improper fractions. So if you have two mixed numbers that you want to add or subtract, you could convert both or all of them into improper fractions and solve them that way, get a common denominator and solve them that way. The other way you could do it is that you solve I won't say solve. I'll say you'd add, or in this case subtract, since we're only talking about subtraction this time, you'd subtract the whole numbers and the fractions separately. Right, subtract whole numbers and fractions separately. So those are our two main options when it comes to subtracting mixed numbers. The first option is to convert both the mixed numbers into improper fractions and then find a common denominator, do the subtraction and reduce. And the other option is to subtract the whole numbers and the fractions separately. Now what I'm going to do is I'm going to go through one example of this. Probably just the one though, because I also want to get through multiplication and division of fractions in this lesson. But so I'm going to go through an example of subtracting mixed numbers using both of these methods. So first we'll do it solving by converting everything into improper fractions and solving it that way, and then we'll switch and try the same problem with the second method. Alright, so without further ado, let's get cracking. We'll start by considering the example, which might be, I have no idea what was the one we did last. So this is different from the one we did before. Yeah, just checking the notes there. But this is different from the one we did for addition. But if you want extra practice with the addition one, then you can just change the minus sign to a plus sign, and boom, you have an addition problem. But so we're going to try and figure out how to turn 3 1/4 minus 1 2/3 into a single fraction. We want to do this subtraction, and we want to figure out how we can get from 3 1/4 and 1 2/3 and get them into something that we can actually work with and then subtract them. So your first step, if we're converting to improper fractions, that's the first method we'll do. If we want to convert both of these to improper fractions, then we'll have to follow that process from before that we talked about a couple of lessons back, where we convert mixed numbers into improper fractions. I'll just use that shortcut that I showed you, which is that you start with this denominator, you multiply it by the whole number, and then you add the numerator. You start with the denominator, multiply by the whole number, and add the numerator. So if I want to do that for this first fraction, I'm going to get denominator times the whole number, that's going to be 4 times 3, plus the numerator is 1, all over, and that denominator is going to stay the same. That 4 is going to come along for the right. and then I'm going to have a minus sign. And then I'm going to do the same process for the second fraction. So we've got denominator times the whole number, that's going to be 3 times 1, and then plus the numerator, which in this case is 2. And then that denominator of a 3 comes along for the ride. So if I solve that, and let me get rid of this stuff with the arrows. I never really liked drawing in that clockwise arrow thing, so I'm going to get rid of it for now, just because it looks a little bit too cluttered for me. But if you like to have those arrows in there, keep them in there. If it helps you remember the direction or the steps or something like that, feel free to keep them in there. So this is what we're working with, right? We started with 3 1/4 minus 1 2/3. Now we're halfway through turning them into improper fractions. We're halfway there. We've got denominator times whole number plus the numerator, denominator times whole number plus the numerator for both of those fractions. Now we just have to go and figure out what those numerators are for the two fractions, for the two new improper fractions. So for this first one, we've got 4 times 3 is, let me throw this up there. We've got 4 times 3 is 12, plus 1 is 13. So we've got 13 over 4. And then we've got 3 times 1, which is 3, plus 2 is 5. We've got a minus sign in the middle, so minus 5 over 3. So remember, those denominators are just going to come along for the ride. So now we've converted both of these mixed numbers into improper fractions. 3 1/4 became 13 over 4, and then 1 2/3 became 5 over 3. So now our next step is to get a common denominator between this 4 and this 3 over here, right? So if I'm going to get rid of the title just because I need the space. So if we want a common denominator between that 4 and that 3, and that's going to be the LCM of 4 and 3, which is 12. So our target denominator for our next line, when we're converting these two fractions into equivalent fractions that have the same denominator as well, we want them both to have a denominator of 12. All right, so we're going to have something over 12 minus something else over 12. Okay, I hope you guys can see everything clearly. It looks all right. Okay, yeah. So we want denominators of 12 for both of those fractions. So if we start with that first fraction, can I move anything? No, I don't. I'll just get rid of this thing with the LCM up here. So with that first fraction, we got 13 over 4, and we want to turn that into something over 12, right? Now to get from 4 to 12, what do we have to do? We have to multiply by 3. 4 times 3 will give us 12. So I'm going to multiply by 3 on top as well, which is going to give me 13 times 3 is 39. So I'm going to have 39 over 12 over there for the first one. And then we're going to do the same thing for the second fraction. We start with 5/3, and we need to get it into something with a denominator of 12. Now going from 3 to 12, you have to multiply by 4. So to get from 5 to our new numerator, we also have to multiply that by 4. And so doing that, we get 5 times 4 is equal to 20, which will go over there. So now we've converted 13 over 4 and 5 over 3 into their new fractions with the same denominator. And now because they've got the same denominator, we can just go ahead and subtract those. And so doing that subtraction, we get 39 minus 20 is going to leave us with 19 as our new numerator, and our denominator is still going to be 12. Now your very last step here would be to convert this back into a mixed number, which basically you look at 19 over 12 and you ask yourself, all right, how many groups of 12 can I fit into 19? You can fit one group of 12 into 19, so our whole number is going to be 1. And then if you if you take out 12 from those 19 to make a whole, what are you left with? That's how you'll get the fraction. So we can make one group of 12. If we had 19 pieces of something, we can make one group of 12, and we'll have 7 pieces left over. So 7 becomes our new numerator, and then we're left with a 12 as our denominator. That just carries over. So then that 1 and 7/12 would be your answer. All right, hopefully that makes sense. If you guys would like me to make an extra video, as always, just let me know. I can make an extra video doing extra examples of this stuff, but for now I'm just going to repeat this question, but I'm going to solve it the other way, and you'll see why it's a little bit extra work, but you might still prefer this the second way, just because you might be dealing with some slightly smaller numbers. In this one we had like a 39 pop up, which isn't, you know, the kindest of numbers to work with. So let me rewrite that problem a lot smaller up here. So we're dealing with 3 1/4 minus 1 2/3. Alright, excellent. Okay, so the second way to solve it is to subtract the whole numbers separately and subtract the fractions separately. So basically we want to deal with the portions of the problem in pieces, right? When we were doing it with addition, we would take the whole numbers and just add them together, and then take the fractions and just add them together. And then we would stick the whole number sum and the fraction sum together to get a new mixed number answer. Now with subtraction, it doesn't quite work the same way, and here's why. When you're going through this subtraction problem, if you get to a point where suddenly one of your answers, so let's say, you know, you're trying to do the subtraction of the whole numbers and you're trying to do your subtraction of the fractions, if one of them comes out positive and the other one comes out negative, it's really easy to get confused of where to go from there, right? It's like when you're doing subtraction of just whole numbers. If you're doing like 123 minus 67, when you go through that process manually, 3 minus 7 causes us some problems. So when the thing that you're dealing with, when the thing that you're subtracting, so that would be in this case the second fraction, when any portion of it is bigger than its counterpart in the first term, it causes us some problems and we have to deal with it, right? So obviously 67 isn't bigger than 123, but if you're just looking at the ones place, that 7 is bigger than that 3. And so we have to deal with that by borrowing from this 2, it becomes a 1, this becomes a 13, and then we can go ahead and do that subtraction. And then we have a similar problem in the tens place, right? So that's kind of what we have going on here. Obviously we've got 3 and a little bit extra, right? 3 and some change for the first term, and 1 and some change for the second term. So clearly the amount that we're starting with is more than the amount that we're subtracting from it. So we shouldn't get an overall negative answer. But just the way that when you're doing subtraction manually, you sometimes got to do this borrowing thing because one of the subtractions doesn't work or would give you a negative number, we have a similar problem over here with subtracting mixed numbers. So instead of talking about hundreds place and tens place and ones place, we're now talking about the whole numbers and the fractional parts of our mixed numbers. So the thing with fractions is it's kind of hard to tell. If I gave you something like 4/5 and 6/7, and I asked you to tell me which of these fractions is bigger. So like, let's say if I asked you to do 4/5 minus 6/7 and tell me is the answer going to be positive or negative, you might be able to figure it out, or you might know your fractions well enough that you can tell, oh, it'll definitely be positive or it'll definitely be negative. But just by looking at it, we don't tend to have as good an idea of when an answer is going to be negative, right? If I told you like do 6 minus 13, you know that that's going to give me a negative answer, right? And you know that it's going to be it's going to also be negative for any other second number that's bigger than 6, right? If we've got 6 minus 20 or 6 minus 12 or 6 minus 7, those are all going to give us negative answers. But for fractions, if I now made it 6/7 minus 13/15, now it's not nearly as clear whether it's going to be a positive number or a negative number, right? So with fractions, it ends up being a lot more work for us to actually figure out if we need to do that borrowing thing that we do when we subtract whole numbers. So basically what we need to do in order to tell whether, let's get rid of that as well, in order to tell whether the fractional component of one of them is bigger than the other, the only easy way to do that works for all the fractions is to just get common denominators for those fractional bits. So for the first term we had a 1/4 as our first fraction and 2/3 as our second fraction, right? And we're trying to figure out, is 1/4 minus 2/3, is it going to be bigger than 0 or is it going to be smaller than 0? That's what we want to figure out, right? That's what we don't know. Is it bigger than 0? Is it smaller than 0? Is it equal to 0? We don't know any of that until we can get a common denominator for those two fractions. So we know to get a common denominator between 4 and 3, we're going to find the LCM of 4 and 3, which is 12. Right? We've already found that from the last question. So the LCM of 4 and 3 is going to be 12. So we're going to take this bit right here just with the fractions. We're ignoring the whole numbers for now, and we're just dealing with the fractions first. So we want to turn 1/4 into something over 12. Now 4 times 3 is going to give us 12 down there. So we do the same thing up top. 1 times 3 will give us 3/12 for our first term. And then for our second term, same idea, but instead of 1/4 and 3/12, we're starting with 2/3, and we want to get that into something over 12. Now 3 times 4 is going to give us 12 for our denominator, so we have to do the same thing up top. We'll do 2 times 4, and that's going to give us 8. Right, so that means our second fraction is going to be 8/12. Now, here's the problem, right? This is like when you're doing 123 minus 67. You can't do that 3 minus 7. You need to borrow from something larger, right? If you're struggling to do that subtraction in the ones place, if it's going to give you a negative number, you borrow something from the tens place, and then you go and subtract. If you're struggling in the tens place, you borrow from the hundreds. If you're struggling in the millions, you'll borrow from the 10 millions, right? So you'll always borrow from that next place over, and that's what we're going to have to do here. So for now, let me get rid of all of this stuff in here, and I'm going to rewrite the fractions that I'm going to rewrite the mixed numbers that we started with, but I'm going to replace the fractions with these new fractions with common denominators. So we've got 3 and 1/4 is going to become 3 and 3/12, because this 3/12 used to be 1/4, and then that 8/12 used to be the 2/3 that we have over here. So it'll be 3 and 3/12 minus 1 and 8/12. Alright, so now I'm going to get rid of all of that stuff over there, just so that we have some space. And now we've got a little bit of a problem, right? We still haven't resolved our issue of this second fraction being bigger than this first fraction. If we try to do the subtraction separately, we can do 3 minus 1 over there, that's no problem. 3 minus 1 will give us 2, but we can't do 3/12 minus 8/12. That's where it becomes a problem. So now we will briefly go back to our pizza and pie analogy, because this first fraction here, what it's telling us is that we have 3 entire pizzas, or pies, or whatever, and then we've got another one that's cut into 12 slices. Right? So we've got, that would be 6ths right there, so that should give us 12ths, something like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Alright, pretend those are all equal sizes. But basically what we have is we've got one whole pizza here. Right, so we've got 3 whole pizzas. So that's 1, 2, 3. And then we also have 3/12. So I'll just color in 3/12 of this last one. So that's what we have that we're starting with, and I want to subtract 1 and 8/12 from this. But our problem is that if you're running a pizza place and you've got 3 pizzas that you could cut if you need to, and you've got 3 slices sitting there, somebody says, okay, I want to come and take one pizza, one full pizza, and then also 8 slices out of a 12-slice pizza. So right now, you could give him the one whole pizza from up here. You could just take one of those and say, all right, here you go. There's your pizza. But then what do you do about those 8 slices? You can give him 3, but he didn't ask for 3. He asked for 8. You can't give him 2 whole pizzas because he doesn't want that much. So you have to figure something out. And so what we're going to do is we're going to take one of our whole pizzas and we're going to cut it into 12 slices. Alright, so we're going to take one of those, we're going to cut this. Am I doing this alright? Yeah, I think I'm doing this way. So we're going to take one of those and we're going to cut this into 12ths as well. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've cut another one of these into 12ths, but we haven't given away or eaten any of these ones yet. So we still have all 12 of those slices. Right, we still have all of those pieces of pizza, but now we have less whole pizzas and more slices of pizza, right? So we used to have 3 complete pizzas that had never been cut, and then 3 slices left over from some old pizza. Now we've got 2 complete pizzas and just this huge mess of extra slices. So I'm going to rewrite this 3 and 3/12 in this new form. We've taken away one of these wholes. We're left with just 2 whole pizzas now, right? This is number 1 over here and number 2 over there. We've got 2 whole pizzas, and then in this third pizza we still have the entire pizza. We cut it into 12 slices, which means we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 slices. We still have all 12 slices, plus we have the 3 that we had from earlier. We still had those 3/12 from before. So in total we've got 2, and then our denominator is still going to be 12 because we haven't cut the pizzas into anything other than 12ths. But now our numerator becomes the 3 that we had from before plus this bonus 12 slices, right, from the pizza that we borrowed from. So basically we took away one of those whole pizzas, so that's why we've gone from 3 down to 2. And then, well, I can't just change 3 and 3/12 into 2 and 3/12. That's just taking away a pizza. So if I've taken away that pizza from this whole number over here, I need to put it back somewhere. And the way I put it back is I add 12/12 of a pizza to my fraction. 12/12 is a whole pizza. So I haven't added or removed any pizza at all. I've just taken one of those pizzas and I've now cut it into 12 slices. So I have more slices at my disposal. And so what I can do then is I can rewrite that second fraction down there. So we've got minus 1 and 8/12. Right? And 3 plus 12, I don't need to leave it written like that, right? I can change that. I'm going to get rid of this diagram now. Hopefully we don't need it anymore. Now we've got, in our pizza shop, we've got 2 whole pizzas. 3 plus 12, that's our new numerator. That's going to be 15 over 12. And then we want to subtract 1 and 8/12. Alright, so now we can go ahead and do this subtraction, because now this fraction here is larger than that fraction there. So that shouldn't give us a negative number when we do that subtraction. And then this whole number here is larger than this whole number there. So that should also not give us any trouble when we go ahead and do the actual subtraction. So let's go ahead and do that now. And just to make absolutely sure that we don't need to change anything else with our whole numbers, let's subtract the fractions first. So now we've got to deal with this 15/12 and 8/12. And if we go ahead and we do that subtraction, we're going to end up with 15 twelfths minus 8 twelfths, which is going to equal 7 twelfths. Right? Maybe I'll put that with like an arrow. Alright, so 15 twelfths minus 8 twelfths is going to leave us with 7 twelfths down there. And then we also have to do the subtraction of the whole numbers. So we have to do 2 minus 1, which is going to leave us with 1. Right? And then we can sort of just, well, we have our whole number here, we have our fraction there, we just stick those together, and there is your answer, 1 and 7 twelfths, which is the same thing that we got last time. Alright, so hopefully that makes sense. This is the second way to subtract mixed numbers. As you can see, it takes a little bit more work with that borrowing thing, and that's a method that I never really preferred when I was in school. I tended to just convert things into improper fractions, but if you prefer this method, feel free to use it. It's not, it works quite well, but you know, sometimes the addition that you're doing can get a little bit ugly, but it is just addition. You know, you might end up doing some really ugly multiplication if you do it the first method. Alright, so hopefully that makes sense. Again, I know I haven't done enough examples, like I haven't done a variety of examples for this subtraction of mixed number stuff. I only did one example 2 ways. So if you want more of that, please let me know, and I will find a way to make some extra material for you on that. Now we're going to move on to multiplying and dividing fractions. So we'll start by ignoring the oh, I'm running out of space. We'll start by ignoring mixed numbers, and we'll just deal with multiplying and dividing proper fractions for the time being, and then we'll come back to mixed numbers a little bit later, because it's not actually that much more complicated. So let's just jump right into it. I actually find multiplication of fractions to be simpler than addition of fractions, which sounds a little bit backwards. We learn addition before we learn multiplication generally, and so we tend to find addition easier. But for fractions, I prefer multiplication over addition, and the reason is that you don't need any of that common denominator stuff that we've been doing with addition and subtraction. You don't need any of it for multiplying and dividing. So with multiplication and division of fractions, it's actually really simple. For multiplying 2 proper fractions like this, the first thing you want to look for, and that's something that we can't do in this problem, is can I reduce either of these fractions? So for example, if both the numerator and the denominator of this one were divisible by 2 or 3 or 5 or something like that, then I can go ahead and I can reduce this fraction to its lowest terms now. I could reduce that fraction to its lowest terms now, but I could also reduce kind of going across. If this numerator and this denominator are both divisible by the same thing, I can reduce those. And if this numerator and that denominator are divisible by the same thing, then I can reduce those. Obviously, we're not seeing that in this problem. 3 doesn't have any common factors with 2 or 7. We've picked 4 different prime numbers here. We can't do any reducing, but you'll see that in the next example, that you can reduce like that. But when you actually get around to multiplying fractions, once you've done all the reducing, which in this case there is no reducing to be done, you just multiply these 2 numerators together, and that's going to be the numerator of your answer. And then you multiply your 2 denominators together, and that's going to be the denominator of your answer. So, on top, it's fairly straightforward. 3 times 5 is equal to 15. And on the bottom, 2 times 7 is equal to 14. And so now we've expressed this product as one fraction, 15 over 14. If we want, we can express this as a mixed number, which, if you convert that from an improper fraction to a mixed number, you can fit one group of 14 into 15, and then you'll have one piece left over. So you should get 1 and 1/14 as your answer. And that's pretty much all there is to it. It's a fairly simple process. There isn't that much work that you have to do with changing numbers around. The reducing the fractions, which you'll see in our example now, in our second example now, it's there to make your life easier. You don't have to do it at all if you don't want to up until the very end. But I'll show you the next problem. We'll do it two ways. One where we reduce at the beginning and one where we reduce at the end. And you'll see how maybe it's a little bit easier to do the reducing at the beginning. So in this next example, what we'll do is we'll do 6 over 7 multiplied by 14 over 8. Alright, now, can we reduce 6 and 7? Like 6/7? Is this fraction something that we can reduce? So, no, it's not. 6 is an even number, 7 is not, so we can't divide by 2. 7 isn't divisible by 3, so that won't work. Neither of them are divisible by each other, so that doesn't work. So we can't reduce this fraction at all. But over here, 14 and 8 are both even numbers. They're both divisible by 2. So if I divide out both of those numbers by 2, I'll replace this. So 14 divided by 2 is going to give me a 7. So I'll put a 7 up top. And then 8 divided by 2 is going to leave me with a 4 on the bottom. So just because it's getting a little bit messy with putting numbers through it and then putting smaller numbers next to it, I'll just rewrite what I have. So we've got 6/7 times 7/4. I don't like that 4. So we've got 6 over 7 times 7 over 4. Now, if you notice, we have a 7 on top, we have a 7 on the bottom. It doesn't matter that they're not both on the left side or both on the right side or anything like that. All that matters when you're reducing is that of the two numbers that you're reducing at the same time, one of them has to be a numerator and the other has to be a denominator. So one of them has to be one of the numbers on top, and the other number that you're reducing it with has to be one of the numbers on the bottom. You can't reduce two numerators together, and you can't reduce two denominators together. It always has to be a numerator paired with a denominator. So if we look at our pairings of numerators and denominators, 7 and 4, we can't reduce that by itself. 6 over 7, we can't reduce that by itself, but if we look across, 7 and 7 are both divisible by 7, obviously, so we can divide both of those by 7, and we're left with 1s in their place. But we're still not finished, because 6 and 4 are also numbers that we can reduce. They're both divisible by 2. So if we go ahead and do that, 6 divided by 2 is going to leave me with a 3 up top, and 4 divided by 2 is going to leave me with a 2 on the bottom. So now it's getting a little bit messy once again. So we're going to rewrite this. First fraction has become, we've got a 3 on top, we've got a 1 on the bottom, so that's going to give us 3 over 1 multiplied by, and then our second fraction has become 1 over 2. And then when you go ahead and you do that multiplication, now it's just that straightforward numerator times numerator, denominator times denominator. So our numerators, we multiply them together. 3 times 1 is going to give us 3. And our denominators, 1 times 2 is going to give us 2. So that would be your answer, that 3/2, or if you again want to convert it into a mixed number, you could turn that into 1.5. That's also a valid and perhaps slightly better way to express your answer. Alright, hopefully that's making sense. Just to show you what happens if you reduce later, we had 6 over 7 times 14 over 8. Now, if you don't do any reducing and you just multiply those together at the beginning, you're going to have to sit there and figure out that 14 times 6, well, 14 5s are 70, plus another 14, that should give you 84. And then 7 times 8 on the bottom is going to give you 56. And now you have this improper fraction, which is going to be a little bit of a nightmare to reduce, at least compared to what we were doing before. Right? Before we were dividing numbers like 6 and 4 and 7 and 7. Now we're trying to find, oh, what are 84 and 56 both divisible by? So it's just a little bit of a mess. You might look at those and think, oh, well, maybe one of them is prime, or maybe they're not divisible by a large enough number. You you can kind of get stuck there and think, okay, well, maybe I'll have to reduce them in steps. It just gets harder. You know, the bigger numbers that you have here, the harder it gets to recognize how much you can reduce them. If you do reduce this, it should still give you 3 over 2 or 1.5, but that's a lot of reducing to do at this stage. So that's why I encourage you to do as much of the reducing as you can in those early stages before you actually go through with the multiplication. Alright, now just really quickly, we'll go through how to divide fractions. And the reason I'm willing to do that at the end of this video, even though it's already been 35.5 minutes, is that dividing fractions is very, very similar to multiplying fractions, and it's just as straightforward, or it's almost just as straightforward. So if you can multiply fractions, you basically know how to divide fractions as well. So we'll keep the same two numbers that we did the first time, which was 3 over 2 and 5 over 7, but instead of multiplying them, we're going to divide them. Alright, now to divide fractions, we don't actually do any division. Division is the opposite operation of multiplication, right? The opposite of multiplying something is to divide it. So the way we actually divide fractions is we take the second fraction that we're dealing with, always the second one. We leave the first one exactly the way it is. We take the second one and we just flip it upside down. We'll take the numerator, we'll make it the denominator. We'll take the denominator, we'll make it the numerator, and then we'll change this division sign into a multiplication sign to account for the changes over there. Because if we just flip that one over and we don't change anything else, one, it still looks like a division problem, and two, you'll have just changed the question because now you're moving around where all the numbers go. So what we do is we flip that second fraction upside down and we switch this division sign into a multiplication sign. So division becomes multiplication, and then to compensate for the switching of the operation, we flip that second fraction. Just remember that it's always going to be that second fraction. Don't flip the first one. Alright, so for multiplication and addition, the order doesn't matter, but for subtraction and division, the order of the terms matters a lot, and you'll get a different answer depending on the order of the terms. So you have to be careful of that. But so if we're doing it right, we've left the first term untouched, switch the operation from division to multiplication. Now we just have to flip this fraction. So instead of 5 over 7, it'll be 7 over 5. And now, again, this is the example that we started with. We can't reduce anything here. So we just go ahead and we just do the multiplication across the tops to get our new numerator and across the bottom to get our new denominator. So on top we'll get 3 times 7, which is 21. And then down on the bottom we get 2 times 5 is 10. And that gives us our one fraction here. It's an improper fraction, which, again, if you'd like, I encourage you to get into the habit of reducing these, and reducing as much as you can, and if you have an improper fraction, convert it to a mixed number. So if we convert this one to a mixed number, we should be left with 2 and 1/10. Alright, now hopefully that makes sense. I can go through more multiplication and division problems a little bit later on. I just wanted to make sure that you guys are getting a glimpse of all of these topics early on, and then I'll make a couple of videos later on in the unit that are just us purely going through practice problems for addition, subtraction, multiplication, division, stuff with proper numbers, proper fractions, stuff with mixed numbers, combinations of addition and multiplication. All of that stuff we will try and tackle a little bit later on, and we'll see how much time we have to get through all of those things in the not so distant future. But I will see you guys in the next video. That's it for this one. Have a good one.